Hi everyone, welcome to Tutorial 1. Since Bergson's article in 1946, we have known that the relationship between the variables associated with hospitalization will be different among hospitalized patients and in the general population. Greenland and Robbins developed this idea to make it more general. If two factors are marginally independent, that is unassociated before stratification, they will be associated within at least one stratum of a variable that they both affect. Anyway, here's the punchline. Two independent causes are conditionally dependent, given their common effect. In this tutorial, I'll show how two independent events become dependent when we stratify on the variable that depends on both. This graph encodes the dependencies between three variables. Note that H depends on both A and B. For this reason, H is called their common effect. In addition, the graph shows no dependence between them. Would this hold if we stratified by the common effect? Stratification means examining the relationship between two variables for different values of the third variable. In a thought experiment, we will create 100 patient records with a history of two diseases and hospitalization using 3 coins. Let's first flip 2 coins 100 times to create the presence of two conditions, A and B. One coin determines the occurrence of condition A. The coin is fair, so the probability of A is 1/2. The second coin determines the occurrence of condition B, with an 1 in 2 probability. When at least one of the two conditions occurs, we flip the third coin. It governs the occurrence of hospitalization by the history of the two conditions. When neither condition occurs, hospitalization is assigned to every 5th case. This is done to make sure that hospital admissions occur in the general population as well. This slide shows the distribution of created records by hospitalization status. The tilde sign means not present. For example, tilde A means A is not present. The numbers are similar between hospitalized and the general population, when at least one condition is present. They are quite different when neither is. You can see that there are only 4 hospitalizations. This may represent hospital admissions for other reasons. And there are 21 records for those who did not go to the hospital at all. When the records are tabulated, each combination of these two conditions occurs the same number of times, 25 in every 100 people in the total population. It is easy to show that A and B are independent. Let me walk you through this calculations. The conditional probability that B is occurring in the presence of A is 25 divided by 25 plus 25, which is 1/2. And the marginal probability of B, also 1/2. This means the probability of one condition does not depend on the presence of another one. They're independent. Let's now show the association between conditions A and B among the hospitalized, denoted here by the letter H. The probability of B, given events A and H, is 12 divided by the sum of 12 and 13, which is 12 out of 25. Almost 1/2. And the probability of B given H and tilde A, 3/4. There you have it. Probability of having condition B is smaller among the hospitalized when condition A is present. This indicates a negative association between them, if you consider only those in hospital. Let me quote Greenland again. If two factors are marginally independent before stratification, they will be associated within at least one stratum of a variable they both affect.